So we will start with what is prompt engineering, what can be achieved with prompting, basics of prompting, elements of a prompt, prompting techniques, tips to design a prompt. So too much prompt, but I think that's also what we are here for. And let me quickly dive right into what is prompt engineering. And to understand this a little bit, I came up with this diagram of an input on the left that you see and an output on the right, right? So whenever we interact with an LLM system, so LLM for context is large language models. Most of our AI tools that we use, ChatGPT, uh, Microsoft Copilot, or Anthropic's Cloud. So there are a lot of, okay, first of all, even before I talk about this, there are a lot of different AI tools that you can use even today, right? So there are tools offered by the major tech giants. There's Microsoft, Google, there's OpenAI, and all of these guys have their own versions of AI systems or AI tools. There are also many small players out there. So if you see Mistral API, Mistral is actually a company in France that is also developing AI tools. So there is quite a variety of AI tools out there. So ChatGPT is not the only one. Just for your information, you can also try to play with Gemini, Mistral, Llama is the open source version that Meta has released, and a lot more. So you can explore these different tools, different systems, and yeah, basically use them as well to try. And of course, DeepSeek as well. I've not written DeepSeek here, but DeepSeek has been the talk of the town recently. So yeah, a lot of different tools for you guys to use. And this is just a brief list. But let me get back to what is prompt engineering, right? So you have this LLM system or large language model system or an AI system in the middle, and you give an input from the left that essentially is what is your prompt. And then you expect an output. But prompt engineering is not only the modification of the input that you see, but it is also the modification of your LLM settings. So each LLM comes with its own settings, comes with its own hyperparameters, if I can call that, where you can tune the output of your LLM based on the setting that you have set for the LLM. So some of the popular ones, I'm sure you must have at least seen this or read about this if you have not used this, is temperature. If you increase the temperature, the creativity of the model generally increases. And if you decrease the temperature, the model actually tends to give more structured responses. Then there's also top K, which selects the top K responses in the next token prediction. And I'm sorry. And there are a couple more that are popular ones. But also what's interesting is different AI systems have different hyperparameters that you can tune or uh, different settings that you can set. So this is also part of prompt engineering, but for the sake of this talk, we will focus on prompt or for the sake of this, this is not actually part of prompt engineering, but I would say this is also part of making sure that the outputs are best aligned to what you are looking for, right? So for the sake of this talk, we will focus on just the prompt part of it. We will try to look at how we can construct different prompts and what are the different techniques in which we can do that. But I also wanted to let you know that LLM settings also play a part in the output you generate. It's not only the inputs that you write, the English text, but also the settings you set the LLM with. So I just wanted to share that with you before we actually now look into a formal definition for prompt engineering. So this is my attempt at defining prompt engineering. I hope someday we see this in a textbook. If somebody is an author here and is trying to find a definition for prompt engineering, here's one for you. So prompt engineering is the science and art of developing and optimizing prompts to efficiently use LLMs to perform various interesting and useful tasks. This is how I define prompt engineering. And what's really crucial here is that it is a science in that there are certain ways that you can actually use to make sure that your outputs are better than just writing regular stuff. And it's an art. It's an art because it's a developing field. It's also little hacks that people use to actually enhance the output in different kinds of ways. So it's also not very well defined. Sometimes people do certain things that are just trial and error, and they find out a result that really works amazingly well for them, and then they preserve that, and then they try to share within their communities, and it's that kind of an art where you think in creative ways to write your prompts to actually get the output that you're looking for, right? So this essentially is prompt engineering. It's the science and art of developing and optimizing prompts. It's coming up with these prompts uh, that you craft to get the output you need, and also optimizing them. So prompt engineering, in my view, is an iterative exercise. Once you write a prompt and give that as an output, give that to the LLM system as an input, and then you get an output from the LLM system, that is not the end of your prompt engineering task. You would rather, and there are different tools also that enable you to actually track your prompts as you keep changing and iterating over them, and maybe we will talk about them in a separate masterclass, but it is also about optimizing your prompts in different iterations to efficiently use LLMs. And this is what we want to do at the end of the day. We have a task that we want to achieve. It could be writing, it could be coding, it could be something about like structured reformatting, or whatever you want to do with LLMs. And we will talk about that in a future slide on the different kinds of things you can do with LLMs. Um, so it is essentially the science and art of developing and optimizing prompts to efficiently use your LLMs to perform various interesting and useful tasks, right? And these tasks vary from people to people. It may involve working with input prompts, LLM settings, and both prompts and LLM settings. And this is what I already set the stage up for you when I spoke about this in the previous slide. So you can work with the prompts which you give as input, or the LLM settings, or both prompts and LLM settings. So this is essentially what prompt engineering is. Uh, I'm sure most of you have done some of these things, but this is an attempt to formally define prompt engineering and also to understand what is possible to do with prompt engineering. Speaking of what is possible to do with prompt engineering, let's look at the common tasks that people use to achieve outputs with prompt engineering or prompting. So one of the most popular ones is, of course, text summarization. You give a text as input to the LLM system and say that, hey, this is too long an input. Can we shorten this or something like that? And then the LLM summarizes that for you. Just give me a second before I continue. I would like to check if my charger is connected because it doesn't look like it is connected. So give me a second. I will join in a second.
Hey everyone, until Imad sir is just checking his charger as we all go through scenarios like that. Stay tuned. Tell me how's your masterclass going on, and keep your all of your questions ready. And as soon as we finish with the sessions, sir will take all your questions. Okay, Sai is here, so over to you.
Sure. Yeah, so if you have any questions, please feel free to drop them in the chat, or also you can keep it with you. We can take these questions towards the end. I will not be looking at your questions for now because I am looking at the slides, and once we are done, we can take all the questions together. Okay, sorry for the minor inconvenience. I thought I had connected the charger, but looks like it was not. Anyway, let's come back to text summarization. Text summarization is a very popular application, and it, there are different ways of using text summarization, right? So in different contexts, like if you're working in a business, you can have a lot of large reports that you would like to summarize. If you're working in the news business, for instance, you have a lot of articles that nobody has the time to read. So you just give it to a text summarizer, and then the text summarizer tells you, okay, this is the summary of this. Um, and Also, like if you're a student and sometimes you have like a larger, how do you say, larger material to study, right? If you have a lot of things to study, you just give to a text summarizer, and the text summarizer can actually give you like bullet points on what you need to actually focus on. So text summarization itself has multiple subsections that I'm not talking about, and it can vary from different, say, businesses, different academic areas, and different genres where you want to summarize text and get like the summary of it, and then use that for your other like learning needs, your business needs, or whatever. So text summarization is a very useful application of LLM systems. Information extraction, and this is also one of uh, the really cool applications of prompt engineering, if you ask me, because what you can do is you can give, especially when you're programming or when you're trying to do a lot of interesting stuff using code. What you can do is you can give something as input and extract your information in a structured format. And this is actually a lot of this saves actually a lot of time, right? Otherwise, you have to write code that makes it in a certain format, and then you have to make sure that it doesn't fail on certain accounts and stuff like that. So a lot of your manual work can be moved to the LLM system. So an example of this would be you have to extract the names of all places from a travel related article, right? So you have an article and you have been given the task to extract the names of all the places in that. So what you can just do, and you can say, hey, this is my article which talks about visiting Taj Mahal in India. And then you say, extract all the names of places that the person wants to visit when they visit Taj Mahal, and then and maybe keep extract all of that as a JSON format, so different file formats, right? Or as a CSV file or whatever it is, and then the LLM can do precisely that and give you what you're looking for. So it's a really really cool application. I have used this application for different like formattings of like different to create different formattings of what I want, and I think this becomes very useful in a lot of business contexts. And I often keep talking about this to people because this is something that they don't realize in the first instance that they can actually do with LLMs, where you can get a structured output format for your unstructured from your unstructured input. And this is absolutely one of the coolest prompt engineering like applications of prompt engineering or applications of LLM systems. Then you have code generation, and this is all the rage in 2025. Like code using AI systems to write code. If you are not doing today, you will start doing it in the next few months for sure, because in the future we will definitely have AI assisted coding for most of our needs, especially for those that do not require a lot of, say, infrastructure work or a lot of, say, specialized knowledge. Especially if you're writing code that is like a CRUD app, create, read, update data. So the common applications where you're maintaining a database, right? So if you're writing CRUD applications, if you're writing front end frameworks, not framework, but if you're writing front end for different websites, a lot of this can be automatically generated by AI. In fact, I was reading the other day, and there was a report that said about 25% of code that is written in Google is generated by AI. I think there was a report or a tweet by Sundar Pichai, who is the CEO of Google. Um, so code generation is a big use case. Um there are also very interesting tools out there in the market that help you do code generation and also make it a seamless process. That's how these tools enable you to write code, right? So of course, there are two ways. One way is, of course, you can just copy paste your code from your ChatGPT or Gemini, whatever, and then put it in your file systems, or you can also integrate using these tools. So one of the most popular tools out there is Cursor. I'm sure some of you might have heard of it. There's also Windsurf. I have tried both of these tools personally, and the things you can do with them are like super fast compared to just copy pasting, because what they can also do is they can inject code in your files and then ask you to review if you would like to accept that change of code or not. And this actually simplifies your workflow significantly, right? Everything is served to you right into your files, like I said, instead of you having to copy paste and then solve for them. Even though we have these tools, I have another like caveat to add to these. So they are almost always not perfect. They have some issues in terms of the code they generate, and sometimes they don't generate the right code and then they mislead you. So the way I usually recommend to use these code generation tools is to know what you're doing first of all. Like, okay, if you're using a particular framework, say React or Vue.js or jQuery for that matter, to write front end, just know what you're trying to do. You should know some background of that. Don't run blind is what I would advise, right? So you just don't assume that you can build stuff and then if the reason why I say this in a foreign language that you don't understand, maybe in Go or Rust or something like that, and then you face issues when you're trying to deploy it or when you're trying to make smaller changes to it because you don't understand it, and then you're stuck in a loop trying to do that with these code generation tools, and that is not a good place to be in. But if you already know the language or if you already know what you want to do and if you really want to get it done quickly, then I would recommend you to use these code generation tools. And I have used these code generation tools, like I said, Cursor, Windsurf. They make your workflow simpler, they simplify and faster. They make everything happen in a more seamless way. So I would recommend you to use these things, but also with a hint of caution that you should really know what you're trying to do. There are also other tools that I have been recently coming across, like Lovable and Lovable.dev, I think, and there's also another one that I'm not able to recall. But these tools are for business owners or for people who actually want to quickly build. Replit is another example that I was not able to recall. So Replit, Lovable, these guys, what they are doing, uh, they're trying to come up with these like just write prompts and then you get a final ready MVP of the product you're trying to build. So this is also an interesting space, but in this case, they are not generating code, but you're actually generating the product itself, right? This is also a very new space, so you will also see a lot of development in this, but it's a very interesting space. Personally, for me, because I come from a programming background and done, I have built products. I don't try to go to that route because for me, I would like to have things more in my control. But I'm seeing a lot of people use these tools as well to actually develop products to come up with MVPs of things they want to build. And yeah, that's also been something that people have been using. So code generation is a very interesting research area or application area of LLM systems. And this is, in my view, one of the biggest changes that we will see in the software industry. You will you will clearly see the way people used to code before the advent of AI tools like ChatGPT, and after there will be a difference. Text classification, and this is a very common problem statement in the industry where we want to classify a certain incoming text as one of these categories, and traditionally you would go and build a categorization system where you would if you have come across the data science life cycle, you would try to look into the data, try to collect the label data, and then build a model on top of it, and then do the evaluations, and then so you used to do all of this before you could come up with a categorization model for your categories. But now you essentially just write it as a prompt and then ask it to categorize, and then you're done, right? So this is the change that we see from the data science way of doing things to the LLM AI way of doing things. It has its own pluses and minuses. This is not the time to discuss that, but this is certainly an application of prompt engineering or of LLM systems where you can prompt in such a way where you can automatically categorize any incoming text into one of these categories. So moving on to conversation, I think most of us have done conversations with our AI tools. Uh, but the reason why I put it up here is because this is probably the most used use case, but also the most under appreciated, I would say, because I remember the time before the advent of these AI systems, we in the industry, people were trying to build chatbots, but these chatbots did everything but chat, right? So they were very structured instruction systems, let me put it that way, right? So you would say, okay, do this, select one of these, then this, then that. So it was very structured, very limited kind of a chatbot. People used to call it chatbot, but it was not a chatbot in my view. And I always had these discussions with my colleagues and stuff and said, I don't think this is a chatbot. But what we have today is definitely a chatbot. There's no questions about it. This is a chatbot. You can clearly chat. It can think, it can respond, it can uh, continue the conversation, right? It can access memory about whatever you had discussed with it earlier. So this is clearly a chatbot, and a lot of people are doing all sorts of conversations. I read about it somewhere that people are building full-fledged applications for mental health wellness, where people can use it as a therapist and stuff. I'm not sure about how useful or how beneficial that would be, but people are trying a lot of different conversation related applications as well, building on top of LLM systems. And some of these you can achieve with prompting. Question answering. So this is also a very valuable use case where you can sort of give a paragraph of information to the LLM system, and then based on that paragraph, ask questions about what you can find in the paragraph. And this is essentially a very useful use case for many industry applications where you have large set of documents and you do not have the time to actually go through them. And then basically you can feed that to an LLM system and then ask the LLM system to, hey, just look at the documentation and tell me what the answer to this question is. Very, very critical use case. You will see a lot of uses of this in the industry. And there is also one technique of prompt engineering that we will see in a few slides called RAG, or Retrieval Augmented Generation. And this is actually one of the most, I would say, most useful use case for industry that people are actually trying to build a lot of systems on top of it. So moving on to reasoning. Reasoning is also a very interesting and a developing area. I'm sure you must have heard of OpenAI's O1 model. I think DeepSeek has its O1 and O3. OpenAI has O1 and O3. DeepSeek has R1. Gemini also has Flash thinking. These are new age reasoning models which can perform mathematical calculations, which can make sure, they do like your physics problems, mathematical problems, and any tasks that require you to think and reason, right? So they can do your deep research reports and stuff like that. So these are broadly the different applications of prompting, and I think some of us have used LLM systems or AI systems for some of these. I just wanted to share a little bit more of all the different kinds of applications that you can build with these LLM systems. Now, moving on to basics of prompting. The ChatGPT version you see in the next few slides is going to be a little bit basic. ChatGPT 3.5. Just a couple of days ago, you saw GPT 4.5 come out. I created this slide basically for ChatGPT 3.5 version because that's what was available at that time, and also it helps me showcase the different use cases. So what you see here might not be reflective of the current versions of ChatGPT. So this is like a disclaimer I usually add when I'm doing these slides, but I use these to explain how the basics of prompting look like and how these systems were originally designed, right? So LLMs are trained to be next token prediction machines. What does next token prediction machine mean? For the sake of simplicity, just for this class or for this session, let's consider each word to be a token. This is not true, uh, but just for the sake of our discussion today, let's consider each word to be a token. The reason why I say it's not true, because it can be at multiple levels. It can be at a token level. It can be at uh, a level of sentences, even it can be at a level of multiple characters put together. There are different strategies that you can use to come up with tokens for each vocabulary. So all tokens put together is called a vocabulary. So there are different tokenization strategies to come up with the best possible tokens for your vocabulary. We are not going to get into that, and that's why I said let's consider, for the sake of our discussion today, that LLMs are trained to be next token prediction machines. What is a token? Token is a word. So if you see the first image on the left, the quick brown fox. This is my input, the quick brown fox. And then the output from ChatGPT is jumps over the lazy dog. Like, how did ChatGPT know that I wanted jumps over the lazy dog? That's a question that anybody would get, right? But if you analyze, and if you just Google this sentence, the quick brown fox jumps over the lazy dog, you will see that this is a very popular sentence. The quick brown fox jumps over the lazy dog is a very popular sentence, and it is popular because in this sentence, you will find the use of all the alphabets from A to Z. And that's why this is a very popular statement that you will find across the internet, discussed in different forums. And as you probably know, AI systems or LLM systems are pre-trained on a huge corpus of data obtained from the internet, right? So the quick brown fox jumps over the lazy dog naturally would appear in this corpus multiple times. And therefore, the systems essentially learn that whenever somebody says the quick brown fox, the next word should be, or the next part of, or the next phrase should be jumps over the lazy dog. So this is essentially next token prediction, where you have existing tokens, you use those tokens to come up with the probability of the next tokens that might come up, and then essentially use that as a prediction and give that as an output. I'm simplifying a lot of things here as I say this, because there are also nuances to how long these next token predictions should look like. There's this concept of n-gram, where you can use unigram, bigram, trigram, and so on. There's a lot of things, and then these are very basic concepts, and there are also other concepts. The attention mechanism is what the transformer systems use, which is what the LLMs are using behind the scenes. So there are different ways of coming up with this next token prediction as well. So like I said, the first thing, there are different ways of coming up with tokens. Second, the different ways of coming up with next token prediction. So for the sake of this class, we will not get into that, but just know that LLMs are trained to be next token prediction machines, but they are not just that. And this is where LLMs sort of shine and are different from the previous generation next token prediction machines. So they are next token prediction machines that can be conditioned on a variety of tasks, and that's what makes them different. So if you see the sentence on the right now, the way I condition it, the way I prompt it, the way I ask it to take my input is different. I say sentence, the quick brown fox, what was the color of the fox and was the fox slow? So in this case, I have completely changed the way I give my input compared to the image you see on the left. And therefore, the output as well changes. And the output now is the color of the fox in the sentence, the quick brown fox is brown. As for its speed, the term quick indicates that the fox is fast, not slow. So the fox is not slow, it is quick. So this is what has happened, right? So now I have conditioned, not just trying to predict like what is the next word in the sentence, but now the condition is like there's a question, and the question, and this I talked about question answering system. So this is in a way a question answering system. So there is like a context, and on that context there is a question, and then the answer is provided by ChatGPT. So I created, or rather I changed the simple next token prediction to a question answering system by changing the instruction, right? So so far I hope you're getting the broad idea of how LLMs function, and how and I'm sure you must have used all of this, but this is a lot more structured way of thinking about how you can prompt. So moving on to creating more structure, I will create more structure in the next slide by introducing you to the elements of a prompt. So far we saw, okay, how does prompt engineering look like? What is the definition? What are the applications? What what essentially it means to do prompt engineering. Now we get into the bones of it. We say, okay, what are the different elements that a prompt has? So it has instruction, context, input data, and output indicator. Every prompt you create can have all of these, some of these, or none. I wouldn't say none of these, because if you have none, you have nothing, no prompt. But you would have either some of these or all of these. And I will explain this to you with an example. So another input prompt that I give to ChatGPT is classify the text into neutral, negative, or positive. Here's an example. Text: I was really happy with my grades. Sentiment: positive. Text: I think the ride was not a lot of fun. Sentiment. And then this is essentially my input. And ChatGPT outputs sentiment negative, right? This is how you build your prompt. You have the first line, the instruction, where you are instructing the LLM system to do a certain task. In this case, I want it to categorize or classify. So I say classify the text into neutral, negative, or positive. Then you have the context, and context is an important aspect of prompting because context helps the LLM system focus on what's more important for you. And in this case, what I'm essentially doing is giving an example that allows the LLM to focus its outputs in a certain direction. Let's just think of it that way, right? So when I give a context, out of all the outputs it can give, it decides to focus on this context and then say, "Huh, okay, you have given me context. I will use your context and give you the output you're looking for." Because otherwise, I am like this big AI machine that I can do whatever I want. But if you give me context, I will focus on your context. So you give an instruction, you give the context, and then you also give an input data, which is essentially what you want to classify, right? So this is, I think the ride was not a lot of fun. And then the output indicator for that is the sentiment. Because you want it in a particular format, right? So output indicator tells what format your output should be. Your input data is the input that you provide, so that that is used as something that the instruction should be acted upon on. The context helps the LLM system or the AI system understand what the instruction is about, or so that it does not hallucinate. I'm sure you must have heard of the term hallucinate. Hallucination is just making up stuff. Again, there is a lot of theory behind that. Hallucination, what is hallucination, what is not hallucination. I'm not going to get into it. Let's just keep it at hallucination. Okay. So you have an instruction, you have a context, input data, output indicator. So you have these four elements of a prompt. Some of them can be there, or all of them can be there, based on the kind of instruction or based on the kind of stuff you want to do, right? But if you structure it this way, you're likely to get a good response. So the reason why I tell you this is also because if I don't give this output indicator, right, it is not necessary that, or it is not likely that the ChatGPT system will output the way it has out shown given the output now. The output now is sentiment negative. And this is how I want this. Like if I'm building applications using these, or if I'm using this for some programming task, I want it to give me structured output. And the output indicator actually helps me do that. So what I'm trying to say is based on your task, sometimes the output indicator is important, sometimes it is not, sometimes your context is important, sometimes it's not. But if you are trying to do something like this, where you're trying to categorize or classify, then the best outcome for you is to provide instruction, context, input data, and output indicator. So these are the elements of a prompt. Like I said, you can pick and choose different elements. You can make sure that all of them are available based on your problem statement. But I would recommend you to like think of the different elements as and when you write, and see if all of them are there, or most of them are there, or something is missing. One quick tip here is to actually include context in most of your prompting. If you do that, you will see a benefit. You will see an improvement in the quality of your responses immediately. And I already told you the reason why, because the LLM system is like this giant AI system, right? It's like I can do whatever you want me, but when you give context, you restrict the dimensionality, or you restrict the sphere of outputs that the LLM system can output, and then you make it think, so-called think, in a certain way. So the context is one of the most, I would say, important aspects of your prompt. Okay, I will move on to the next section of our session today. And this is essentially the last and the largest section, where we will look at some of the prompting techniques that exist out there. I don't know if you've heard of any of these names. I'm sure the last one is the most popular one, Retrieval Augmented Generation. You must have heard that to some extent. Chain of thought prompting is also a popular one. Zero shot, few shot, these are also slightly popular. So we will go through each of them individually one by one and understand them completely. It's not very difficult, even though these names make it sound complicated. And my hope at the end of this these prompting techniques is that you start using some of these prompting techniques in your prompts. Okay, we are coming to the last section and the biggest section. So it's not 5 minutes; it's more than, I think, around half an hour, I think. But let's quickly get started. So zero shot prompting, and this is a very popular, common way of prompting. Everybody does this. This is not something that you have not done this. I have done this. You have done this. Anybody who has used an AI system has done zero shot prompting. This is basically like classify the text into neutral, negative, or positive. I think the ride was not a lot of fun. Sentiment, and then sentiment is neutral. What is the difference between the example I showed you earlier and now? As you might have already noticed, there's no example here. There's no context here. And this is why I was talking a lot about context. So if you don't give context, if you don't give an example, and if you just ask the LLM system, hey, I want you to do this, go ahead and do this, right? That is called zero shot prompting. So classify the text into neutral, negative, or positive. This is my text. Give me the sentiment. This is zero shot prompting. And if you see the answer, and this is true for ChatGPT 3.5, not true for any of the newer versions anymore, the answer is wrong. Sentiment is neutral. It was, I said, ride was not a lot of fun. How is this a neutral sentiment? Right? So the earlier systems, this is one, I think, 8 months, 9 months. In the world of AI, 1 week is 1 year anyway. So yeah. So classify the text into neutral, negative, positive. ChatGPT 3.5 does not actually get it right if I do zero shot prompting. Today, this problem is solved. The newer systems can get it right with zero shot prompting. But back then, zero shot prompting could, like in this example, not get it right. So what does zero shot prompting mean? Zero shot prompting essentially means that you do not provide examples and you just give your instruction, your output indicator, and your input. That's it. If you remove context from the elements of a prompt that I showed you, if you remove context, that is zero shot prompting. And it's called zero shot because there is no example. Zero shot. Okay. This is zero shot prompting. No example prompting. Just give an instruction, give an input, give an output. What is few shot prompting? Few shot prompting is where you give few examples. It can be one example, two examples, three examples, few examples. So you don't need to have 1 lakh examples or 2 lakh examples, but few examples, right? Classify, and how do you know how many examples are good? You can sort of do like a trial and error. You can also set up evaluation metrics. That is a little bigger topic, but simpler way is just do some trial and error. You give few examples, you see if you're getting the output right or not. If you're getting it right, then it is what you're looking for. Anyway, moving on to what few shot prompting means. Classify the text into neutral, negative, or positive. Here's an example. Text, I was really happy with my grades. Sentiment positive. Text, I think the writer was not a lot of sentiment. Sentiment is negative. Now it gets it right. What's the difference between zero shot and few shot? The difference is the example. And this is and I have done this session before as well. I shared with other folks. If you want to take one prompting technique, which you can easily use in your day-to-day life, I would suggest you to take few shot prompting because it automatically improves the quality of your output and it's not very difficult or complicated to use. So that is another tip that I have for you if you would like to actually do few shot prompting, give examples, and then you have, of course, your input and your output indicator, and then all of them will actually get you the output that you need. Moving on to another interesting prompting technique called meta prompting. And meta prompting is essentially you providing the recipe of your prompts, recipe of your outputs to the LLM system or the AI system. So I will explain this to you with using the example that you see. So this is actually from a research paper from 2024. Uh, it is actually talking about how to find the roots of a quadratic equation. I'm sure all of us have studied quadratic equation in school. What is the format of, or rather, what is the form of quadratic equation? So it's generally ax squared plus bx plus c is equal to 0. And then you have x is equal to minus b plus or minus root of b square minus 4ac minus b plus or minus root of b square minus 4ac by 2a. So this is how you get the roots. And then essentially when you substitute the values of a, b, and c, you get the roots of your equation. This is how you find the roots of a quadratic equation. And this is essentially the recipe of finding the roots of a quadratic equation. What do? You take this recipe and give this as input to your LLM system. The LLM system, and then finally you say, here's my new problem. I want you to solve 5x squared plus 2x minus 1 is equal to 0, or something like that. Any new equation you want to solve, use the recipe that I shared above and come up with the final answer. This is meta prompting, where you use your recipe, give that as an input you include your recipe as input to your LLM system, and the LLM system uses the recipe to come up with the final answer that you're looking for. And this is particularly useful for mathematical problems and problems that involve computation, right? You can also use this for generating text. One of the examples that you would see here is without meta prompting, you would just ask, what are the benefits of renewable energy? With meta prompting, you would say, think step by step and list 5 benefits of renewable energy. Then, for each benefit, provide a brief explanation. Identify one challenge associated with it. So you sort of prime the LLM system. You tell the LLM system to go through a certain process and use that process to come up with the final answer. Similarly, without meta prompting, solve the quadratic equation x squared minus 3x plus 2. Then you say solve the quadratic equation x squared minus 3x plus 2 using the quadratic formula. Think step by step, show all the steps involved in solving it, and explain each step clearly. Also, check your solutions by substituting them back into the original equation. If you formulate your prompt in this way, you are automatically improving the quality of your output. And this is a new sort of newish because it was developed in 2024 by Zhang et al. A technique that is being used to get better results from your LLM systems, and this is called meta prompting. It's not very difficult. It's essentially the way I like to remember this is you providing the recipe of your dish to the LLM system, and then the LLM system cooks. Yeah, anyway, I will move on to the next and very interesting prompting technique called chain of thought prompting. And this technique is one of the most popular techniques out there that is actually being used by OpenAI researchers and AI uh, Anthropic or Google or Gemini, whatever researchers. It is not very, I mean, it's also used by common folks like us. But the reason why I mention this is because chain of thought prompting is one of the key techniques used in the development of reasoning models that you see. So if you see the O1 model or the O3 model and the R1 model from DeepSeek, O1 and O3 are from OpenAI. These models are called reasoning models, and these are different from your GPT models or your Cloud Sonnet models, which do not have this reasoning component to them. And the way they build this reasoning component is by doing inference time compute. It becomes a slightly more technical session on how they are adding reasoning to the existing models. But what they're using is essentially chain of thought prompting. But what is this chain of thought prompting? Now, very quickly, let's look at this example, and then I think it fits right into your head. It's not very complicated, but it's a very effective technique to make sure we get the right answers. So this is another research paper that was written in 2022. Standard prompting. So you have like a regular, again, math problems are slightly difficult for LLM systems, or rather very difficult because the reasoning solves for it, but very difficult because you had to reason for it, right? You cannot just remember stuff in math, and that's why math you have to go stepwise and then come up with an answer. So this is what you see here. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Now each can have 3 tennis balls. How many tennis balls does he have now? Answer to that is 11. And if you do the calculation, you will get 11. Next question. The cafeteria has 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have? The output of the model is 27. That is wrong. The mathematical calculation is wrong. But how can you make the LLM system get the mathematical calculation right? And the way you do that is by chain of thought prompting, where you use the same examples, but you change the way you provide the answer to the example. So the question is Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can have 3 tennis balls. How many tennis balls does he have now? The answer to that is Roger started with 5 balls. 2 cans of 3 tennis balls, each is 6 tennis balls. 5 plus 6 is equal to 11. The answer is 11. So you do not just give the answer, but you also give the way you would come to the conclusion that the answer is 11. So you say 5, 2 cans have 3 balls, so it's 6 balls, so 5 plus 6 is 11. Now you give your question. The cafeteria has 23 apples, they use this, and when the LLM is trying to calculate the answer, it will use your context. It uses, like I said, I said this earlier as well, the LLM uses your context. The context can help you determine how you want the LLM to think. And in this case, you introduce chain of thought prompting by asking the LLM to use a particular chain of thought to solve the question. And this is what chain of thought prompting is. You ask the LLM to go through a certain chain of thought, and it uses that chain of thought and comes up with the answer that you're looking for. So the cafeteria has 23 apples originally. They used 20 to make lunch, so they had 23 minus 20 is equal to 3. They bought 6 more apples, so they have 3 plus 6 is equal to 9. The answer is 9. And this gives you the right answer. Just a small change in your input prompt, in your input context. Just a small change, you introduce chain of thought prompting, and the answer is correct. This is the advantage of chain of thought prompting. And chain of thought prompting really works well. And that's why researchers have doubled down on this and are now, like I said, creating reasoning models. We will briefly look into the different types of chain of thought prompting. I will not go into much detail. Um, but I think one of them that you can easily adopt is zero shot chain of thought prompting, right? We already know what zero shot means, so you don't give any example. And that is also possible for you to do if you really don't know how to solve the answer, right? So you say, I don't know how to solve the answer to this question. In the previous question, of course, you knew the math, but in this case, let's say you don't know. So what you can also do is you can just say, think step by step, and it works. So it works to some extent. It's of course not probably the best possible way to chain of thought prompt, but I would say it's a better prompt to create than just without things step by step. So types of chain of thought prompting: zero shot chain of thought prompting. Add a think step by step line to your prompt and let it think step by step, and that is your first type. Second, manual chain of thought prompting. So you give the LLM the example of how to reason through the problem statement. And this is what we already saw in the previous example, where we give the LLM not only the answer, but how to come up with that answer. And then the LLM basically uses that logic to come up with the answer when it is calculating, right? So you see examples here. I'm not going through the examples that you see on the screen. So there is one zero shot prompting on the left. There is one manual chain of thought prompting on the right. It's very similar to what I just said. In the first case, you just add things step by step. In the second case, you manually provide the logic. But this is cumbersome, right? So you have to keep doing this every time. So what people have also suggested are different ways of automatically doing this. So there's this automatic chain of thought prompting, which will generate reasoning chains automatically and improve their quality by using a sampling technique, and use the generated reason chains to generate a final answer. This is slightly more complicated, but this is essentially what I was talking about when I was talking about in the context of reasoning models, where where they're using automatic chain of thought prompting techniques, which will allow you to generate these reasoning chains automatically, and then you use a sampling technique that will allow you to select the best possible subset of your answer or best possible answer, and then you use another LLM to finally generate your final answer. So to get into the details of the auto COT method will take us some time and it's slightly complicated. But what I will just talk about, or rather, I will share if you're interested the link to the research paper later, and you can go and read it and understand what is happening with the automatic chain of thought prompting. Okay, so this is all about chain of thought prompting. It's a very useful technique. A lot of people are actually, in the case of researchers specifically, are actually doubling down on this and building a lot of stuff. There's also there's also like another technique, self consistency prompting, that is sort of chain of thought prompting. In the way that you do it is basically you have your input, chain of thought prompting, and you do these multiple generations, and then you finally come up with a majority voting of which generation is the right generation, and then you give that as output to the user. Self consistency prompting and auto chain of thought prompting sort of overlap, because in both cases you have multiple chain of thoughts being generated, and then you use a technique to finally come up with the best output. But this was also being developed as a separate prompting technique initially. Moving on to generate knowledge programming. This is a very interesting generate knowledge prompting. Sorry, this is a very interesting prompting technique where you can divide your task into separate steps, where the first step is essentially generation of knowledge, and then the second step is using the generated knowledge performing the actual task you want to perform. I have an example task here. So if you want to write a blog post on cars in Germany, that is the task that you want to do. You can either go to the LLM AI system and say, write a blog post on cars in Germany, and then it will come up with whatever it can come up with. Or you can use generate knowledge prompting, which allows you to make a better sort of blog post essentially, because it allows you to focus on the generated knowledge and then use that to come up with a blog post. So write a blog post on cars in Germany. Sorry. The knowledge generation part would be generate 10 facts about cars in Germany, right? You're not actually writing the blog post here. You're telling, okay, Tell me about the cars in Germany. Then you do task prompting, which is essentially what the task is. You use the above generated knowledge and you come up with a blog post. And then your output essentially is the blog post on cars in Germany. So this is one way of splitting your task into different sections and then using or rather chaining each section to come up with the final output, right? So you had one task of writing a blog post on cars in Germany. You split that into two different LLM calls or LLM tasks, knowledge generation, task prompting with the generated knowledge, and you chained them together. So this is essentially what we call prompt chaining. So this is also a prompt chaining. Prompt chaining is a way of prompting where you can chain different prompts next to each other, and where the input of one prompt is dependent on the output from the previous one, and then you chain them together and come up with a final output. So generate knowledge prompting is another popular, not very popular, but it's another. Uh, it's popular in the context of using AI agents. I don't know if you've heard of AI agents, but AI agents are like semi-autonomous units that perform specific tasks. And in this case, what you try and generally do is create different AI agents that can specifically do a certain task. And when they do a certain task, they coordinate with each other and then they come up with the final output that you're looking for. So we sort of use this principle when we are trying to build up AI agents because we want specific agents doing specific tasks. But for the sake of our discussion today, this is one way of prompting and coming up with your outputs. Next, moving on to tree of thoughts. This is also a very interesting way of prompting. And the underlying principle is to provide the large language model an opportunity to explore multiple branches of reasoning while self evaluating as it progresses. I'm not entirely sure, but I have a feeling that tree of thoughts is also incorporated in the reasoning models that we see today. But that's also probably because they do a lot of internal processing and then they come up with the answer, right? So I think they have tree of thoughts, but another way to essentially remember what tree of thoughts method is that it constructs a tree of different thoughts, a binary tree or a tree with multiple nodes, and then it tries to eliminate these nodes and come up with a final node, right? So if you have studied data structures, you have binary trees, or you can also use LLM systems uh, to essentially use these data structures. Uh, and different tasks that you can use, right? You can do breadth first search, you can do depth first search, you can do uh, find an element in your, you can do searching, you can do sorting, um, bubble sort, all of these things. So you can use these techniques in your prompts, and that is essentially what the LLM systems would basically use to come up with the answer. So if you see an example that I had actually asked this LLM system about, so answer the following query using the tree of thought methods. Only after you list the thoughts, rate them and build upon the promising ones, creating a new set of thoughts. Repeat until a conclusive answer is found. That is, do a breadth first search. Organize the entire response in a markdown table format. That is my instruction. And now my input. Query: what is the most important thing in life? So I asked ChatGPT 3.5 to tell me what is the most important thing in life. But the way I want it to do this, in a way, I'm also doing meta prompting here, right? So I'm giving it the recipe. Answer the following query using the tree of thoughts method. But in that recipe, I'm giving another recipe. So it's like meta prompting. So I want you to use tree of thoughts method. Only after you list the thoughts, you will rate them and build upon the promising ones, creating a new set of thoughts. And you will repeat this until you are able to do an entire breadth first search. So, like I said, you can use your data structures knowledge, you can use your tree of thoughts to build different trees, and then the meta prompting. So, this is multiple prompting techniques put together to answer this question, that is, what is the most important thing in life? Now, I hope you're ready to see what's the most important thing in life. But before I go to that, I would like to see what do you think is the most important thing in life in chat. What is the most important thing in life? Can you drop your answers in the chat? Happiness is one answer. Money, contentment. Okay, we have three answers: happiness, money, contentment, passion, freedom, peace with what you have, fulfillment of purpose. I know the answer, of course, that the LLM gave. Parents, very important, but is that the most important thing in life? We will find that out now. Okay, I think we have a few answers. Let me, even before I go, right? Even before I go and start talking about that, somebody has answered purpose. Okay, self actualization, parents, marriage. Can somebody help Aditya get married? He thinks it's the most important thing in life. I will ask this question to you after you get married, Aditya. But okay, moving on. Let's really go back to our slides and see how ChatGPT does it, right? So it comes up with a set of thoughts that it considers for the most important things in life, and it gives its own rating: love, happiness, purpose, health. We see some of these in your answers as well: fulfillment, family, success, contribution, inner peace, personal growth. And then it gives an initial rating, and then it says, okay, I have all these thoughts, I've given them an initial rating, and these are the promising thoughts. Love is rated highly. It's often considered fundamental to a fulfilling life. Happiness is crucial, but can be subjective and fleeting, and so on and so forth. So it gives its rationale for why it thinks these are important, right? So this is the first part. Then it expands on it. So it says, okay, I have love, I've given it a 9, and this is my expansion to love. Encompasses various relationships and connections, not just romantic, but also friendship, compassion, and empathy. It fosters a sense of belonging and fulfillment. Happiness is an 8. Pursuing activities that bring joy and contentment is essential. It's also about finding contentment in everyday life and so on. Purpose is a 7. I think some of you guys mentioned purpose. Discovering one's purpose involves understanding personal values, passions, and making meaningful contributions and so on. So it family is a 9, inner peace is an 8, health is a 7. Then what it does, it prunes or it shortens the thoughts because it has identified some of them, the top 2 or top 3, whatever it does, and then it says, okay, now I have these. And then I expand on that again. And then finally, it gives me one conclusive answer. It says the most important thing in life is love, particularly the love we share with our family. This love provides a sense of belonging, support, and fulfillment, while also fostering inner peace and resilience, ultimately leading to a deeply satisfying and meaningful life. So now you know what you need to look for in your life, I hope, answered by an LLM. So, marriage, of course, is one of them: the love you share with your family, love you share with your parents, and love you share with the most important people in your life, at least according to the LLM. I know some of us also said self actualization and purpose, but the LLM thinks love is more important than that. So I mean, this is a fun example, of course, but you can also use this kind of a prompt or a way of asking for other important decisions in life. For example, like, should I take the job abroad or should I continue to work in India? What are the pros and cons? You can ask it to evaluate that, and then it keeps evaluating, and then it comes up with an answer. Or should I take up a course with Amers, or should I do something else? Evaluate the pros and cons and come up with a final answer. All of these things, LLM provides you with a structured way of answering difficult questions or questions that require a lot of thinking and reasoning, and also gives you the reasons for why it thinks it provides the score that it does. So this is another prompting technique that you can use to come up with answers to questions that require deeper thought, deeper analysis, and finally come up with an answer that you're looking for. Last technique that I have for today is RAGs, or Retrieval Augmented Generation. This is a very popular technique, and in fact, if you ask me, I can do an entire session of 2 hours on just RAGs, because RAGs has a lot of different components. Uh, I just show you a very brief flow diagram of all the different components. You see question, retriever, large language model, response, context, but each of them can be a, like I said, half an hour, 1 hour session. But what does it actually mean, right? So you have the large language model, you have the response. So we understand. Large language model, response. Any AI system, LLM, whatever you want to call it, it will give you a response. But before we give an input to the large language model, which is our question, if we have a question, we use a retriever, and the retriever references a context which is basically constructed from your custom document, and enhances your prompt. Let me explain it very simply. If you have a very personal document, right? Document about the events in your life. When were you born? When were you? When did you graduate? And stuff like that. You wrote that in a document, right? Now, this should not be common knowledge on the internet, because this is not, you're not a public personality. Nobody really knows about you. Or if you have written down in LinkedIn and other places, maybe that is also there. But let's just assume you're not a public personality, but you want an LLM system to answer questions about you, right? So you would write that in a document, you would create embeddings from that, and then you would provide that as context to your retriever, and then you ask questions. What is the age at which I graduated? Something like that, right? Or what is the age at which Imad graduated? I just asked this question. I have given this documentation, so it can use the knowledge that I provide as context or a custom document, and pass my question as in the prompt. This knowledge, both of them add and become a super prompt, and that prompt is passed to an LLM, which uses that question, the context, like how we would use in few shot prompting, and then using that context, it comes up with a final answer. What you have done in this process is you have created an engine or a system that can answer questions on your custom documents. And this is a very, very valuable use case for many industries. You have banks who have a lot of different documents, and you want people to ask, get question, and like this is a very valuable piece for customer support. Let me just put it that way. Any industry has customer support, right? You want to provide support to your customers. You have your lot of documentation. How can you provide them a easy to use chat interface where they can use your custom documents and come up with question answering system where you can ask any questions and then can get the answer, and then you can basically have a conversation. So I mean, in our parents generation we used to have product manuals. In our generation we will have product chatbots who will not just be the manual but will also talk to you about, okay, what more do you need and stuff like that, and then try to provide an answer to you, right? So this is the evolution of technology. RAGs is a very useful use case where people are using to build a lot of different and interesting and cool systems in the industry. And yeah, so RAG, I'm not going to talk much more about RAGs. Maybe RAGs is, like I said, it's a full-fledged system, a full-fledged session where we talk about how the context is formulated, how the retriever can be selected, what should be the parts of your question, and how should we choose an LLM. So each of the components you see here is also a decision you need to make when you're building a RAG system. Yeah, so that is about retrieval augmented generation, or RAG. And with that, we have covered all the different prompting techniques that we wanted to talk in our session today. And finally, I just want to leave you with some tips while designing a prompt, where I would like you to start simple. So use only instruction or question, even though I mentioned all the different elements of a prompt: instruction, context, question, or your input and output format. Start simple, use only instruction or question. If this is able to give you the answer that you're looking for, then you don't need to do much more. But if you think the answers are not as per your satisfaction and you would like to get a deeper answer or a more precise answer, then I would suggest you to add more elements and context. If zero shot prompting does not work, try few shot prompting. And like I've already told you, few shot prompting is one of the techniques that I would recommend you to try, often because it's not very complicated and you can easily add a few examples that you're trying to for the task that you're trying to solve for. Be very specific in your instructions, uh, giving a very if your input prompt is very vague and generic, the outputs are also likely to be in that way. You want to be very specific about what you want the LLM to do. You want to be as precise as possible. Let me just put it that way. Explicitly mention output format if you specifically need the output to be in a particular format. This is also a very important point because, especially for programming tasks, you will need the output to be in a particular format, because if you want to build like APIs on top of it, or if you want to use it for other downstream tasks, you want the output format to be reliably in a particular format. So this is an important part that you will have to do if you really want to stick to a particular kind of output. So do that and keep iterating. So you will never, or never say never, but you will most likely not get the output in your first iteration. You will want to keep iterating until you get the right outputs for your task. There are also a few tips, you can also do role play, and I did not write it down here, but I'm sure you must have come across that. You can say, as a mathematics expert or as a programming expert, do this. Some people do this role play where you ask the guy to assume a role as a doctor. Can you tell me what are the things? It helps to some extent, and yeah, I think that's also another area in which you can sort of improve the outputs by asking the LLM to assume a personality. So, as this, can you do this? And I would suggest you to also try that for specific tasks that you are looking to solve for. Keep iterating and happy prompting is all I would like to say to end of our session today.